Okay. Today, what we're going to do is continue on with what we talked about the other day. In the last session, we had a couple of points that we plotted, and we found the distance between the points. We learned how to find the midpoint between 2 points. We reviewed some things about the Pythagorean theorem and basics on the idea of slope. We also talked briefly about intercepts. And so today what we want to do is I want to give you a real quick summary of the concept of slope of linear functions or straight lines. And then we want to talk a little bit more about intercepts. We want to review the development of the equations of a straight line, which is stuff you've seen many times before, but half of you have probably forgotten some of the elements there. And then we want to talk about circles and the equations associated with circles. That's going to relate back to some of the basic stuff that we even talked about in the last session. Okay? So here we go. Here's the idea on slopes. We know that slope equals change in y over change in x. The Greek letter delta is to indicate change. Change in y over change in x. If you take a Cartesian axis system and I put some line segment on there between 2 points, then the change in y is this rise, and the change in x is the run. Now I'd like you to observe a couple things about these points that I put up here. This right-hand point, let me go ahead and label it using some algebra, x subscript 2, y sub 2, and this other point, x sub 1, comma, y sub 1. And notice that this second point over here on the right is up at this height, y2. This point is up at a height y sub 1. Just like two people standing next to one another, there's a difference in those heights. That's the rise. So y2 minus y1 is that height, is that rise. Very basic. I'd say this exact same thing in a beginning algebra class. So we have y2 minus y1, and it's getting a little cluttered up here for the rise. Similarly, what's this run between the 2 points? This right-hand point over here, you can see, is way over there at distance x2. This first point is only over this far, x1. The difference between those two distances is the run. So that's x2 minus x1 being the run. So that's the fundamental concept worldwide and historically for defining slope. Anybody asleep yet? Okay. Now, let me show you a quick summary of how the slopes vary. What if, I'll just use my arm, what if I have my arm at a 45-degree angle here? Isn't the rise the same as the run if I'm exactly at 45 degrees? So the slope there would be what? 1. Slope of 1, right? If I run positive 1 and rise the same distance, the slope is 1. 1 divided by 1 or 10 divided by 10. In any case, these rise and run values are the same. What if I put my arm down at 45 degrees downward to the right? Negative 1. Because the line, as I said last session, is falling to the right. If you come from this point where my elbow is, drop down a distance, and then go that same distance in the positive x, that ratio is negative divided by positive, equal values being the ratio being 1. Okay. So, if we have a general sketch, something like this, then if I'm right on that 45-degree line like this, anywhere, doesn't matter where you place it, the slope there is going to be equal to 1. If I was horizontal, what's the rise between my elbow and the end of my hand? The rise is 0 divided by whatever this length is, the run. 0 divided by whatever this length is 0 over a number, non-zero, is 0, right? So the slope here of a horizontal line is going to be 0. What if we had a line that was less than 1 but bigger than 0? Something like this. If you sketch it like I suggested the other day, if you sketch it, you can see clearly that that rise is smaller than this run. And so the slope in here is somewhere, the slope of this segment is somewhere between 0 in value and 1 in value. So the slope in here is trapped between 0 and 1. What if the line was steeper than 1? A slope of 1. Something like this. You can clearly see that the rise is greater than the run. The numerator will be greater than the denominator. So up in here, the slopes are greater than 1. Steep lines. Similarly, the same sort of thing happens if lines tend to be falling to the right. If you're here, we said a few minutes ago, the slope is what? Negative 1. And this slope here on a horizontal line is 0. And so that means the slopes in here must be trapped between what values? Between negative 1 is smaller than 0, right? So slopes in here must be trapped between negative 1 up to 0. In a similar fashion, if the line is steep but falling to the right, you can see the rise here is greater than the run. These slopes are negative. They're more negative than negative 1, aren't they? So the slopes in here are smaller than negative 1. Quick review. What about vertical ones? I put my hand here vertically so it will show up on the camera. There, okay. If the line is vertical, the rise is the distance between the points, right? That might be what? Oh, say 1.5 feet, okay? But the run between the top and bottom here is 0. So we'd be dividing by 0, which is undefined. So slopes of vertical lines are undefined. Vertical line slopes are undefined. That's beginning algebra. You all know that. Okay, let me jump now to talking about lines, since we're already have kind of a good start here. There's several ways that we could explain the equation of a line, and I want to try to do it probably slightly differently than what you might read in the textbook or some other instructor might offer. So let's do the following, just because this is college algebra and not a beginning algebra class. Let's say I have some point. Let's call this point x1, y1. And let me draw a line. Now that line has some slope, doesn't it? Has some slope. Feeling good? Okay. I'm not telling you what it is, but it's, in this case it would be what kind of a slope? Positive slope. And be a little more specific. Positive, but what? Did I hear greater than 1? Less than 1. Positive, less than 1. You're going to see me holding my arm up here a lot during class. And what I'm going to be saying is something like, what kind of a slope would you see here between my elbow and hand? Something less than 1, positive. For instance, it might be something like, think of this as maybe 1 to 3. Do you see that? 1 roughly to 3, maybe 1 to 2. It looks like it might be a 1/3 or 1/2. In any case, it's positive and it's less than 1. Okay. Let's say I'm going to come up with some other point out here. Now, I'm not going to tell you where that point is. So if you don't know something in math, what do? You give it a symbol, don't you? If you don't know something, that's an unknown. So you oftentimes give it a symbol. Now, if I'm talking about that being a point, I might just call it x comma y as an ordered pair. X comma y. How tall is that point? How high is it?
Higher than the other one.
Higher than the other one, maybe. It's this height, isn't it? So isn't that y tall?
Okay. Yeah.
Isn't that y tall, everybody? Okay. Isn't this one y1 tall? Okay. So the rise there is y minus y1. Right? Just like the other picture I had back here earlier, this thing is up here at height y, and this point over here is up at a height of y1. And the difference between those two heights, like an NBA basketball player standing next to me, the difference in our heights is that rise. Everybody with me? Okay. What's the run?
X minus X.
X. X is this distance. Take away this distance, x1. So this is x minus x1. Okay. Here's a graph or a sketch, which I've been emphasizing since the first class session. Draw a sketch if you can. So, what's the definition of slope now for this particular problem? M equals y minus y1, the rise, divided by x minus x1. Now this is called a fractional equation because it's got a fraction in it. So if I want to clear the fractions, I multiply both sides by this common denominator. What's the denominator over here? 1. This is m over 1. What's the denominator here? X minus x1. So if I multiply both sides by x minus x1, what happens here? Those factors reduce out, don't they? And we end up with, I'm going to rewrite it in the other way, I'm going to put the y stuff on the left, y minus y1 becomes equal to this slope times x minus x1. This is called the point slope equation of a straight line. The point slope equation of a straight line. Beginning algebra. If you forget this formula, just derive it like I just did. Okay? Not too tough. Any questions? Let's keep rolling. What is missing on my picture as far as a point goes? What point are you familiar with? The intercepts. Well, this line has, it looks to me like it's going to have a y-intercept right here, doesn't it? A y-intercept right at this point when x becomes 0. We normally call that value, what's this height right here typically called? In your beginning algebra background. What letter? Well, yeah, it is a y value, but we typically in most textbooks call that b, right? Little b. Remember that? Well, I hope so. If you don't, your memory is worse than mine. Okay. Normally that's called a little b. But we could use any letter, couldn't we? It's some y value there. Okay. So, does this thing have some y-intercept, this equation? Well, hold it. I saw some heads shaking no. Does this thing have some y-intercept? I saw some heads going no. Yeah. Isn't this an equation that describes this line? If I gave you a point x1 and y1, and I gave you some slope, then doesn't that give us a relationship between the changing x value and the different y value? Changing different y values? Okay, so there's a relationship that exists between the unknowns x and y that we started with. So let's solve this thing for y and see what this intercept is. So how do we do that? Solve for y. Oh, I gave a suggestion to you the other day in class. I suggested you put some English comments in your work. Okay, here's an example. Solve for y. So you look back later at your notes and you will understand what you did. So how are you going to solve this for y? Folks are very...
one side.
Okay, we're going to kick this y1 over to the other side. It becomes positive, doesn't it? And then aren't we going to go ahead and distribute out this stuff over here? Use our distributive property? Okay, so let's step that along. So I'm going to get y equals, on the right I'm going to distribute and end up with a product m times x. And then I have m times a negative y1, so that becomes a negative m x1. And I'm now going to move y1 to the other side. It becomes a positive y1. Okay. Now this is the general kind of formula, isn't it? But where are the numbers in this thing? Where are the numbers? X1 and Y1 are numbers, aren't they?
And M is a number.
And M is a number. Okay, so that means this stuff over here is going to be a number, isn't it? Okay, so let me cluster that together by adding that stuff together, and that thing is the thing you've seen before but maybe you forgot about. That's the value of B, the y-intercept up here on the picture.
What happened to your negative sign?
Oh, I lost it. Remember I told you I do make mistakes, okay? So thanks for catching that. This is actually a negative.
And then the other one has to be negative too, right?
Oh, hold it. Aren't I adding to m times x this mess?
Okay.
Okay, and that term is positive, right? Okay, so I have that. I'm adding all of this stuff here, and you can see how I clustered that in a parentheses. You probably haven't seen it done quite this way before. But you can see now how this connects back to something you saw back in beginning algebra. This formula is called what? This is called the slope-intercept equation of a straight line. Slope-intercept equation of a straight line. This tends to be the easiest way for you to do your sketching. Let me do a real quick example because I've got a couple other topics we need to make sure we get through today. A quick example just to put some numbers in here. How many of you get nervous with all these letters floating around in algebra? Okay, that's not unusual. How many of you play a musical instrument? Were you nervous when you first started? No? What kind of instrument? Clarinet. Back there.
Guitar.
Guitar. Others? Guitar.
Banjo.
Banjo. Were you nervous when you first started playing banjo? Yeah. Particularly when you walk into a lesson or have to get up on a stage and do a recital or be in a band or something, right? Okay. Same thing in sports. First time you walk out on the field in a sports team or something, usually you're fairly anxious until you demonstrate and feel confident in yourself. Same kind of stuff happens in math. You're going to get better with playing with symbols, and part of my job is to help you get over that anxiety. So we want you to develop ability to sort of have a sense of what these things mean, and then with practice you'll get good at it. So here's a quick